And I'm going to share my screen in a moment here. Here we are for the first of our summer mentor sessions. Just going to crunch this down here, put this up in the corner. Coding and command-based programming. We cannot build Rome in a day, but maybe a few bricks we'll put together tonight, a few coding lines together to move along the pathway to support all of Ontario's teams with coding their robots. And unfortunately, I put a 2022 in there. I meant to put a 2023. I even made this page fresh today. I didn't copy it, but I don't know what happened. So our topics are fairly simple: coding and command-based programming. And our introductions have been done. So we will proceed right in to the first big issue with coding and command-based programming. And this may answer Gilbert's question. Trying to do a direct transfer of code from, say, time-based to coding or sort of command-based may not be so effective. But maybe starting from something simple and working up to what you had before is especially much easier if you are now starting out. So installing the software involves installing Visual Studio Code and WPI-Lib. And it's important to remember where you will download the Visual Studio Code. There was one time a few years ago that I thought, oh, I'll just install Visual Studio Code. So I went to the Microsoft site and installed it. And then later I was wondering why WPI-Lib was not working. Well, there's a reason for that. It's because there's a special version of a Visual Studio Code that comes wrapped with WPI-Lib that puts all of everything together. And it's a little bit of an uphill battle to get it working without it already pre-installed. Interesting to note, I've always said WPI-Lib. I met one of the founders in Houston earlier this year, and he says WPI-Lib, but I still like lib and I'll use it. So I'm going to go to a Google page and type in FRC control system. And actually, it would even be better to put the year 2023 in there. FRC 2023 control system. And hopefully the first item that comes up is what you would want. This is valid for now until perhaps later in the fall or sometime early in the next year when they'll switch to the 2024. So you might want to keep an eye on updates for that, so you'll be aware of when to change to your 2024 code base. Right here on this page is an extremely valuable collection of support for your team to do not only building and connecting the robot, but installing the software. I'm going to step 2 here on the side menu, installing the software. And you'll note that some teams do lab view. The game tools, that's a separate thing for your drive station and the like that goes on the computer that's going to connect directly to your robot. But if you want to do programming, you go down to this 4th point here, the WPI-Lib installation guide. So having clicked on there, this afternoon, I did a fresh install of the 2023 WPI-Lib. And how did I do that? I just scrolled down right here. I did not click on this downloads button, although you probably could. Let's see what happens when we do that. Oh yeah, it works, I believe. If we scroll down to the bottom of this GitHub page, at the bottom there, you'll see the download files for each operating system. And I downloaded my Linux one. You'll have to pay attention closely. You may need to know which hardware your Mac has, whether it's an ARM or Intel-based distribution, and there's only one for Windows here. So that's the first step. You download and then install this software. It's different for each operating system, and they do have some instructions that are particular to each operating system. And you'll need to follow those. It's actually in the form of a virtual disk for Windows, and you right click on the file and use the mount command. It's like putting in a CD or DVD, like in the old computers. In the Mac, you're dealing with a DMG file, and you'll see that here. Probably double click on it or something and it will just work. And with Linux, that's a whole other story. Glad to help anyone who's using Linux. Feel free to contact. So I'm not going to go through that process, just to suffice it to say you have to pay attention to which one you download and which instructions you follow, depending on which computer you have. And let's assume then that all has been successful and you follow all of these instructions, scrolling down quickly. Then let's take a look at my desktop. I only keep one thing on my desktop for arbitrary reasons. Maybe more than one thing. Okay, I run an FLLT, more than one thing. I've got 3 versions of FRC VS Code on my desktop, and I've kept the other ones for legacy reasons because I have code in each one of them. So at the moment, there's my 2023 VS Code, and it's a shortcut right on my desktop. When I double click it, it opens up my VS Code IDE, or Integrated Development Environment. Now, in previous sessions, we have discussed some of these shortcuts, what all of these side palette buttons do, and it would be very much worth your while to review that and be familiar with it if you're going to be doing coding. Our session this evening is not about that, and you're very much encouraged to go and learn some of the basics of VS Code prior to trying to work with it. So you do need to know some things, how your code has been set up in the system and configured, what configuration files, what programming languages are installed, what extensions that you're using, and often you may need to install an extension depending on the function that you're trying to achieve. So this often comes through researching examples. Another very important thing to know some of the shortcuts. I'm just going to go through one this evening that we'll need. Control and Shift with the P button gives you a whole set of commands. And you can see the one that I looked at previously under WPI lib, there's create a new project. The fact that it shows up with WPI lib indicates to me that I have the correctly installed version of VS Code that already has WPI lib activated. And then you can see many examples for C and C++. And also, if we scroll way down, there's some also Java content here somewhere. Yeah, there's some Java there, but there are many other commands. You don't need to know all of them, but you probably will use some of them based on tutorials that you may take. And there are a whole bunch of functions particular to WPI lib. And again, we're not going to go through those this evening as our focus is on the command-based programming. The reason, though, that I spent a few minutes discussing this, you need maybe to look at keeping things simple, and a fresh install is one of the best places to start. So this is a freshly installed VS Code. I actually haven't done anything with it except to generate a blank command-based program framework. So all I'm going to do right now is show you that process. I'm going to create a new project, and I'm going to select a template, and it's going to be a Java template. And here we are, command robot. There is what it is. Now I need to find a new base folder. I'm just going to put it on my desktop temporarily, as this is going to be example. And I'll call this example FRC Java. And team number, well, I always put in my old team number 6162, and then we will generate a project. So this one ends up on my desktop. Okay, and you will see the computer giving you a little bit of a status report as it's unpacking the files in the new directory. The command-based programming framework and involves a whole directory full of files, whereas the timed robot generally is programmed within one file unless you start extending it. That's one key example right off the bat. If we look at the source folder, SRC, then we go down into these directories. Here is our Java FRC robot directory, and we have two directories, commands and subsystems, and then several files. So that's where we're going to begin in terms of taking a little tour of the command-based programming framework. Just going to take a little pause for a moment, go back to the Zoom here, and just verify if we have any commentary. Please feel free to chime in. I can't always see your hands, but I'll stop periodically, and I'd be very happy if anyone would offer some commentary or suggestions. So for example, here we have a question about a GitHub area for getting a robot up and running. And indeed, first of all, GitHub is an amazing place to find sample code, and I have an example of that later in our discussion this evening. And it integrates with VS Code, and we also discuss that in another session at another time. That's a whole other entire hour-long subject, just to become familiar with the background of Git. Actually getting it working in VS Code is fairly straightforward, but understanding what's happening in the underlying GitHub takes a little while. So luckily they've streamlined it and made it fairly straightforward to download and update GitHub repositories and share code between numerous people. So if there are any questions, please feel most welcome to chime in, and we will go back to our discussion of the command-based framework here in a moment. Okay, so now let's go back to our presentation. We just installed Visual Code Studio Code bundled with WPI-lib, and those two came together. And very important just to remember to use the first Inspires related links, FRC 2023 control systems, so that you get the right version of the VS Code software.
William, can you share your screen again?
Oh, so sorry. Oops, here we go. So I was just actually one page back, and I was just commenting there before we go to the next page. All right, so our next page here, actually this slide is in the wrong order. I had meant to cover it first, so I'm just going to go slightly out of order on our slides here. Some general things to keep in mind. These are just having reflected on numerous years of using VS Code and FRC programming frameworks in my class. I'm sure you may have some other suggestions as to some general considerations. First of all, keeping your code updated. First of all, it's updated from year to year, and sometimes they have software updates partway through the year, and keeping attuned to the updates that come through First Inspires and or First Canada may help you. In particular, the American site is focused on those kinds of announcements. You can also follow on that same website and just be aware of the need to update your VS Code. There are some commands in the VS Code that you can use to update your WPI-lib, and you may want to look those up and use them. Learning the VS Code's shortcuts and commands in that connection is very important. It helps to streamline your work and get things done more efficiently. Choosing your directories carefully. I've ended up a few times with directories within other directories which were not supposed to happen. Keeping your directories separate between projects is a very important idea. So make sure you're in the right directory and that you save your new projects in separate and distinct directories to avoid overlaps and other unforeseen issues. One story that could have saved a few hours of work. There was one time we were trying to get command-based programming working, and it turned out later that the one snippet of code was from an outdated example. And so we couldn't really detect that. If for some reason it passed the programming, it was fine in some respects. It looked like it was supposed to work. It was legal Java code. It just was not legal Java code within the updated framework. So using up-to-date examples is a very important consideration, and your error messages should be able to help you with that. If someone would like to chime in, please feel most welcome. So learning from the code of others also magnifies our abilities, and the internet is simply full of excellent examples that will help us to understand what's happening. One caveat, though, if you do download the code of others, chances are you may have to adapt it to your particular setup in terms of motor controllers and sensors that are on your robot and your team number and the directory structure and the like. So you may have to copy and paste sections of others' code into your code and make it work accordingly. And speaking to this comment about migrating a timed robot to a command-based robot, starting with something simple and working gradually towards more complexity tends to work. If you get the wheels working, then maybe you can also get a sensor working and then work up to your full robot, and so on and so on. And being patient. In this world, many people expect and hope for instant solutions. Sometimes you do have to be a little bit of a patient coder, looking for the right solutions and then finding a way to make it work with your code. So being very creative in trying different things often helps here. And just be like a child with a kind of a sense of wonder and not be too worried about whether or not it's going to work. And if it's taking a little time, then you can always reach out to someone else for a little support. So those are some general considerations. I hope that these will help to make your work in the command-based programming scheme a little more manageable. And some of these also apply to other ways of programming. So now, in particular, with respect to command-based programming concepts, we divide our robot conceptually into subsystems. Oops. And in past examples of my team's robot, on our 2020 robot, that's the last time I ran a team with command-based programming, we had a subsystem for the base, which included the wheels or the four motors and their motor controllers. And then we had some encoders on them. And that was our drive-based subsystem. Then we had another subsystem for the intake and another subsystem for the shooter. And then we had a fourth subsystem for the color wheel spinner. So our robot attempted to address all the possible ways in the game because we also had a subsystem for the climber. And each subsystem is parceled off from the other parts of the subsystem in such a way, or the other parts of the robot in a sort of a logical way, so that when you access one subsystem, you're not interfering with another subsystem and so on. And each of your commands, that's a whole other area of the command-based programming concepts, they work on the subsystems. So for example, I might have a command, lift the arm, and another command, spin the arm, or some other function. If those two commands use the same motor, they cannot be issued at the same time. And there is a command scheduler in the system of command-based programming that keeps everything in order. It's like a traffic police officer for your commands, making sure they are done in an orderly fashion. You do have to read a little bit about how you get things going in these command-based programming schemes. So each of these commands and subsystems have default Java methods that you're expected to override and create your own code within them. Each of them, for example, has an initial or initialize command, and then another command for ongoing operation, and another command for termination, for example, of the particular command. And that's the basic overall concepts of the command-based programming. The subsystems occur in their own folder. Each one of the subsystems generally has its own file, and the commands likewise, they're in their own subfolder, and each of the commands has its own file. The files then are managed in this general way. There's another one, robot main. We can just take a look at a few of these files in the main folder. I didn't get all of them, but in general, we have a few configuration files in the main folder, and then we keep our commands and subsystems in separate files in these subfolders. And that's a general commentary about the file structure. Let's take a look at it on the actual system here. Here's our directory. There are 2 commands here in separate files. And here you can see the initialize, execute, and end methods that come with this example command. And this code is generally going to be executed once. And then while the command is executed, then this second one, this execute command is running, and whatever is in here is going to be an ongoing sort of set of commands or code lines. And then finally, if you end, then this is what happens when the command ends. Interesting. There's another one here that tells if it should finish. So for example, maybe when it's executing, if the counter is greater than 100, then we can set the is finished to return true. So you might have to put some extra code in here to reflect that. Right now, this is basically a framework for your code that you have to populate based on your knowledge of Java and what you want your robot to do. So that's just a very brief tour through 2 files in the robot commands subfolder. What about the subsystems folder? So here's a subsystem, an example subsystem here. You'll note that both the commands and subsystems, they import certain common file packages from the Java WPI-lib framework, the command-based and the subsystem base. And I will bet if I go here, it's going to be just the command base. Oh, and there's an example subsystem. It was just imported because it's been pre-programmed here. All right, so those are the subfolders. We'll take a look at a little example code as we go on. Our main.java is a very short sort of few lines of code, and it's just starting the robot. We go to robot.java, and this is where we start a robot container, and the robot container has some example code in here that starts connecting us with some commands. So for example, here is a system trigger. If, for example, the controller button is pressed, it might trigger this command. And when that happens, then you're going to execute that command in the robot's code base. This is where we may stop for a moment and think about our timed robots. In a timed robot, maybe about every 20 milliseconds or so, it executes the commands one by one in a big loop. And for example, if we're in the teleop periodic, it's going to continue on executing those commands very frequently during your robot's operation. In this command-based sort of framework, there's a whole collection of commands that are just waiting there. They're not running through a loop. It's simply if your robot notices that a certain condition, such as a trigger, has happened, someone pressed the button, then it will know where to execute the code. It's a different way of thinking, this event-driven programming, and it may take a little getting accustomed to if you've been doing timed robot programming. All right, so one more file here, our constants.java file, and it contains interesting or not interesting, necessary data that pertains to the whole robot. For example, you may have a whole bunch of different ports here for different aspects of your game controller and or the ports of your motor controllers. And generally, whatever constants you need, if you need a certain amount of time for a certain arm to move, maybe it's stored as a constant in here. And there are numerous examples online that can give you a better idea of what these are used for. So that is the basic file structure that goes with our command-based programming framework. So there may be questions, and please feel free to join in if you may have a question. So Arjun has a few comments in here. That's an interesting sort of comment about the change from auto to teleop. In practice, in a match, it's kind of done automatically because you get 15 seconds where the robot is automatically executing auto commands. And after those 15 seconds, it's switched into teleop. In your build space, when you're just testing the robot, you may probably end up running one or the other right from your robot controller program, and you select that in your robot controller program. I'm not sure if Arjun has an additional comment about that, as you've written a comment here.
Oh yeah, I just typing it out. Might be faster to speak though. I think as far as I understand it, the robot.java is structured in such a way that autonomous init basically allows the user to pick an autonomous command during the I guess just through driver station. And typically, yeah, auto commands have a known end condition, like reaching a set point. And so between those two, being able to pick your autonomous command and between the set point, that's kind of how they run. But a lot of this is just very low level stuff that's already been coded in WippyLib, how it connects with the field and all of that.
That's excellent. There's another way to pronounce it, WippyLib. So you may get
yeah.
WPI live, WippyLib. Okay, it's all up to you. We can maybe see an example here to clarify for Randall, because there are some examples that show one snippet of code for the teleop and one for the auto, for example. So thank you, Arjun. All right. Taking a look a little bit more detail on commands. The command methods are three different ones: the initialization, execution, and ending. And we've already looked at those in the code base. And just looking over here in our Visual Studio, going to our commands example. Here's an example command. It starts here and it includes all of this code here, and by default it has those four methods, and in this case this is like a Boolean variable, I suppose, that is returned like a method: initialize, execute, and end. I specifically mentioned, and you may code accordingly. So that's what I was referring to here. You can read more details about these in the FRC control system documentation, which is online. And what are some of the things that we have for command properties? So some of the properties are able to what we call get requirements. For example, the command may need to know what subsystems it's using, and we get those requirements. We also may need to set a property for the command. Does it run when the robot is disabled? For example, you would not want to run a motor when the robot is disabled, but you may want to measure something on an encoder when the robot is disabled, so you can diagnose what's happened with your robot. And for example, is your command going to be running no matter what? Or can you have the command interrupted by another command. And that's a concept that comes with understanding command-based programming. We may tell the robot to move forward, and it'll keep moving forward once you've told it to move forward. However, maybe there's a timer going on. If the timer reaches 20 seconds, then we're going to interrupt and tell it to move in a turning sort of pattern. So we may interrupt the move forward method or command with a turn command by interrupting it. And that we have to make sure that our move forward command can be interrupted. And there are several kinds of commands or types of commands that you'll find. One does an action. It may read a sensor or set a motor. It may also be a command just to wait. And it's waiting for some condition to happen. And then finally, there are more sophisticated sort of collections of commands that are control algorithms. For example, the WPI lib comes with PID control, which gives you smooth operation of sort of robot arms or robot motion. And that's a whole collection of code that's executed with one command, a PID command, for example. So you may execute a control algorithm like a PID using the command. So these are some of the things you may want to look into more, and they are documented on the website. And another exercise might be to find these in a set of code that's on another robot. So to go along with our commands, we have our subsystems. And each subsystem we can think of as a collection of hardware on the robot that may be accessed through commands. And the example I gave was my 2020 robot from my classroom that had 5 subsystems on it, one for the drivetrain, one for the intake, one for the shooter, one for the spinner, and one for the climber. And that actually made it very nice for coding, as we could have several students at one time working on different subsystems and different commands to go with the subsystems. The interesting thing is that the command scheduler, as I was mentioning earlier, it ensures that only one command at a time has access to a subsystem to avoid confusion, because that would make it possible, for example, if you're saying move forward and move sideways, maybe one motor is trying to go forwards and backwards at the same time. That may not work so well. So you have to tell it one motor at a time is being accessed, or one command at a time is being accessed, so the motors know exactly what to do. The declaration of the subsystem, it kind of cordons off that set of motors and sensors from the rest of the code, and they can only be accessed through public methods. Inside a subsystem are some private methods that may speak exactly to what port, and some details about these hardware devices that don't need to be seen by the rest of the program. For example, you may just use the command lift the arm, and inside the subsystem coding, there are some private methods that specify what's the port of the motor that's running that arm. And that's all hidden away from the rest of the program. And that's the idea behind the subsystems. We use private methods to get down to the hardware details and hide that from the rest of the program and access it only using publicly available methods. We can see an example here, perhaps in our code base. Let's go to our subsystems and the example subsystem. So here are a bunch of public methods, and there was no private one in this one. I'll have to find another one as we go. These ones would be accessed by throughout the whole code base, but in here we also may program something that starts with a private note and only is available internally to this subsystem. So that's how it's been created. So you can access this subsystem from outside the subsystem in another file, but you can't access the private aspects of the subsystem that are being hidden away. So I was searching online, and the first team that came up with a command-based programming framework was Team 27 Rush. happened to meet one of the mentors of that team on the way to Texas this year. Great team to look up. And as we're speaking about GitHub or GitLab, what is this one, GitHub? We have a public repository of code for Team 27 Rush's 2022 robot. And that's really nice that many teams make public their robot code. Last year at this time, we had a presentation from Team 1114, for example, which has posted many of its robots codes or code bases online. So there are numerous folders here, and we will note there's a commands and a subsystems folder. There are some other ones there, and I was not really speaking to these as these have been customized to build on the command-based framework. You'll see the main robot, robot container, and constants. Let's just take a look at how these compare to the one that was shown in the example template. So here's our main. Not much is done with this main file. It's pretty much there to execute our robot base program. Now here in our robots.java, we import some of the subsystems and commands that are needed to get our robot started. And the basic idea here is we're starting a robot container. So the main starts the robot starts the robot container. And now we're getting down into our more detailed commands and subsystems by importing particular items from our WPI lib repository. So there will be much more detail in here as compared to the other ones. And here's, for example, let's just go down through the code a little more slowly. We are defining some of our, well, here's our game controller and power distribution and pneumatic hub elements in our hardware. And these ones look to be subsystems in the robot. We'll probably find these in our subsystems folder. And there's a climber, color sensors, a whole bunch of these subsystems. And going down into our robot container, we define them up here and we instantiate them in our main robot container method. And now down here, we are connecting actions on our game controller. When we hit the left trigger, then we're going to create a new command. An interesting thing here, this is an inline command that is defined and executed sort of all in one line, as opposed to another approach. It's to define it somewhere else in the program. You will see this in the documentation that you can choose to define your commands as inline commands in your Java code and read up about it. So this instant command is to call the cargo manager and set the state. So we've pressed a button and we are looking for cargo, I would suppose, not having seen their robot. And we go through the driver controller and all the different actions like button A and the stick going left and trigger right. What do all the controller controls do in connection with our commands? So that's something you might want to review and study and think of an Xbox controller and then just imagine a robot and how it's being connected to the controls right here in the robot container file. So if you were to adopt this in your code base, one suggestion may be to just start with one of these. Just connect the trigger left button to a command or a subsystem in your robot. And that will save a lot of headache, keeping it simple and then one by one adding more commands. taking an example from the ones here as a good example of all the different buttons you can connect to commands and subsystems. All right, so just scrolling down, there's a lot more that could be said. As we're talking about, well, how do we choose autonomous? When you're about to start your robot in a match, you use your pull-down menu and decide what your robot is going to do in the autonomous. And these are a bunch of autonomous routines that are in the selection for this team's robot. All right, and some of these are just maybe default methods that were not used by the team. All right, so that's the robot container. What about constants? And here are a bunch of constants that were defined by the team. For example, maybe the CAN bus ID for some, there's a Spark Max motor and it's on channel 26, for example. We have the index wheel, it's on the CAN bus 28 channel. And here are some conversions to metric for the American teams. 24.25 inches high. Well, that's how high the camera is, defined as a constant in metric. A nice method there for Americans to use, or those Canadians inclined to use imperial measurements here and there. And I could probably go through a lot more. Not knowing the robot, you can imagine that you can define all kinds of data for your robot that will be accessed at the right time by the rest of the robot's code. All right, so those are the main directory files. We're not going to go into these other ones as these are specialized, but let's take a look at perhaps we can look at the subsystems to begin. And there are the subsystems that correspond to the definitions in this robot container file. Let's just look at one or two of them. How about the climber? Now the climber is a subsystem, and now we can see we're using a Phoenix motor control that has to be specially added into your VS Code. That's a whole other story. And there it's importing the constants file and even a separate file, the calibrations file. We could probably find that. You could probably find some more detail that the team added into a custom subdirectory calibrations that allows it to do calculations on what it needs to do to climb. Now, here are a bunch of private sort of data that is defined, devices, specific devices here. This looks to be a pneumatic mechanism on the robot, and it's going to be hidden from the rest of the code and probably only available through the public climber. So we maybe execute the climber command, and it's going to do a bunch of things that access these private solenoid devices and whatever else. This will prevent some other stray bit of code from accidentally setting one of the solenoids from somewhere else in the program. So it keeps it all sort of locked up and safe from stray code getting at it. All right, so lots of detail for this team. I know for a fact our team's code was not anywhere near as sophisticated, and we got it to do some pretty nice things. So you don't have to be daunted by this very long base of code. You can add to it gradually. And in many cases, my team did start to get files like this. We were doing more timed stuff in that instance. And it starts out short and simple, but by the time you're done developing, you get many lines of code. All right, so this is just a very brief sort of travel through the climber subsystem. The climber subsystem looks to be using, for example, these items, some talons and some pneumatic control and the like, and solenoids. And then we access it using a public method that manipulates the private data of the robot. So you can find here anything that starts with private is being done internally. And when we're talking about periodic versus auto, here we have periodic inputs. I would guess maybe something like this would be used for a teleop periodic, whereas the auto would be a separate one. I wonder if we could look that up. Oh, there is no auto in here, so maybe it's not being used in auto. All right, we could dwell on this lengthy file more, but I think just a little commentary to tie what's in this file to what we discussed before was the objective of this discussion here. I'm sure you could do something similar with all of these files. Let's just go up one directory and go down into a command and see what it looks like to call the climber. I wonder if there's a climb. Config shot spacing, wanted state, move path planner. It doesn't look like they have one, so I'm just going to just choose a simple command, move, then shoot with the limelight. And this particular command uses 4 subsystems: the cargo manager, drivetrain, hopper, and launcher. And then they're going to be coordinated in the way that they are activated. All right, so here's a bunch of private sort of detail. The only public part is this. We're going to move, then shoot with limelight command. And inside it takes care of all the details for the programmer. So once we initialize, we're going to do some commands just to get it all set up. And then when we execute, there's a whole sequence of things. This is their planned out set of tasks that should be done in order to get a clear shot at the target. And you may want to look at that code and think of a robot lining up and then shooting. So at a certain point, oh yeah, it's going to be finished this execute command, and hopefully it will have shot. Oh, set line life shot. There's a whole bunch of things that could be happening here. We want to just look and reflect. All right, this may be a good point at which to stop and have a little discussion. There are a few comments here, so we'll just take a moment here. And I see Arjun has very kindly given us a few details here. And wondering if there are any comments or questions about this in the meeting chat. So yes, once again, please feel free to jump in if you have a question, and we'll continue. Oh, I see Gilbert, you unmuted.
Yeah, I was going to ask, so the default has an example command and an auto command. What is the process, like the steps to add like a new command or a new subsystem?
So
like I need want to define a new subsystem, so I need to create a new folder and copy and paste and edit, or like is there a way to set up the link between the different subfolder and the files for a new command or new subsystem?
When we start a new programming project with the command-based framework, it gives us these subfolders already and an example file. So if we go back here, main and robot are basically main starts robot and robot starts robot container. In here, in our robot container,
sorry, can you share the screen?
Oh, sorry, I unshared again. Thank you so much. Here we go, and share. The this set of files comes with a blank command-based template, and the main and robot, they are basically design one starts the other until you get down to robot container, and from the robot container, it's calling our commands here. It's it contains references to the commands folder. And so here we have a command Xbox controller. So this should, if everything is okay, connect to a file in our commands. For the best one here is example. So we're configuring the bindings of an event, such as a joystick or controller button being pressed. And when that is true, then we call this example command. So you see the name example command corresponds to this example command, a file here in Java. And the example command now is making a reference to the subsystem's example subsystem. So these files are linked together systematically through file names, which are case sensitive and must be exactly replicated to make sure that they're referencing the right item. So this importing example subsystem, we should go down here now to the subsystems folder, and we find a whole file for this example subsystem. And now this example subsystem will make use of some specific hardware inside the subsystem. And for more examples or ideas about that, we can go back to that Team 27 Rush code, for example. I don't know if that answers your question, Gilbert, but I was trying to point out that these references in each of the files corresponds to a whole other file in another folder in many cases.
Right. So if I have I want to create a new command, for example.
Yeah.
I copy and paste this file and rename, name it like example command 2.
Yeah, you could do that. And then
it will automatically recognize it because it's in the same folder.
But I would actually follow the whole pathway. So for example, here we execute the example command with this particular example condition. So I would also make something like this, but having example condition 2. And then we call example command 2. So that's the first thing, we have to reference it here. Then we go to our example command, and we could make a copy of this file and call it example command 2. And then it's working on subsystem 2. And then we go down into our subsystems, and example subsystem 2 would be copied from here. And then finally, we have to make sure that that corresponds to real hardware on our robot. So not only would we use this code base to do some copying and pasting, we would also follow the examples that we see in our commands and subsystems subfolders to make sure that we have the right idea happening. So I'm not sure if that still helps, but I suppose using the template combined with another example might help you get going. So you might, for example, try to implement a single subsystem and a single command in addition to the ones that are there in the template and get them working step by step.
Okay.
I guess.
So that is easier said than done. And it is easy to miss a step. And that's why I keep on referring back to this example, because there are subtleties with different aspects of the Java programming that may make it slightly more than what I'm saying.
Yeah, there's something else in the WPI live system. If you right click on the subsystem folder, one of the options at the bottom here is to create a new class or command. And then you get a pick a command option, an empty class command, instant command, blah, blah, blah. Subsystem is part of that. Trapezoid profile command subsystem. I'm not sure what those are,
perfect.
but yeah, but that gives you sort of a template, I guess, of the type of thing that you're after. I guess, and based on the question that you're asking, you probably use a command and subsystem templates accessible this way, and not necessarily some of those other ones that are probably somewhat specialized and I have no idea what they do. So
That's
we'll have to
perfect. That
figure
was
out as we
exactly
go.
what I was hoping for. Thank you so much.
Yeah,
Thank
no
you,
problem.
Peter.
I
That's
guess,
good.
yeah.
So there's a great use of the WPI lib, and lots of these context menus can be used to solve problems like that. So thank you so much for the clarification. We will maybe having taken a look at Team Rush's command base, that brings me to the end of the presentation. I'm sure there is more that could be done, and we are just sort of getting started. I'm just going to stop sharing for a moment and see if there are any more general questions. Oh, thank you for the links there, Arjun.
Yeah, I guess generally the best practice they say is to just take the latest example subsystem from their website documentation, just because you might be copy pasting like old code. And
yes, and that is sort of a bridge that we have to cross. And it is good to mention that for example, if I go back to the VS Code here, we can go to this command palette, Control and Shift and P, and I can create a new project, for example, again, but in this case, I can select an example and a Java example, and now maybe there's something that is command-based in here. There are many of them. There's much more variety in the examples now than there was before. I'm not sure how many of them are command-based. Select command example. Okay, Rapid React command bot. Oh yeah, there's a fully functional command-based fender bot for the 2022 game. So maybe that's a good example there. And so example command 2022. Okay, so when I go to this project, yes. And just to sort of emphasize what Arjun just mentioned, this is now a code base that contains, hopefully, once it's done here, subsystems. I don't know where the commands are.
I think in this example, everything is just an instance command.
So there's
So
just one, maybe one main command or something. So it's not in a sub folder.
for
Oh,
the
yeah.
little default commands.
And box controller, drive. So maybe that's not the best, as it doesn't have this command subfolder, but it does draw from the most recent code. So this might be another place to start and compare and contrast with your computer or your robot, and maybe adapt something like this to what you have. So it does take a little patience, and it is a fair bit more complex in the file structure or organization, but the advantage being organization and reusability of your code, and the ability of multiple students to be working on separate files at the same time, so that they're not trying to manage Git versions between modifications of the same file like you would be doing in a timed robot. And wonder if there are any other similar projects here. An example from Java. We're just scanning down through here. Many of these are very simple, and they often refer back to the timed robot. In command base. So there's gyro derived commands. We can maybe look like that, or look into this one and see what happened. whoops, it looks like my WPI lib just froze. Oh, that's why. I have to select a folder here. Gyro drive commands, and we'll call this gyro. And going down into our source folder, now we have commands and subsystems. So this may be a slightly better example that corresponds with what we were talking about this evening. So I think you really have to use a little bit of wisdom. The basic framework has almost nothing in it. The teams that have posted code have an awful lot in there, more than you're bargaining for, and perhaps the examples balance it out with just the right amount. But again, may depend on the gyro that you have access to. So this one, not sure which gyro it is using. Oh yeah, there's the ADXR 450. It's a common gyro, so perhaps you would be able to use this without too much difficulty. So there we are. Well, it's been a really great pleasure to be with all of you this evening from all around the province, and your comments, questions, and contributions to the discourse has been also most appreciated. I hope that we can build off of this discussion this evening to plan a few other future sessions, perhaps on Python and or vision related to the coding. And perhaps we may do something like that when we get to our Studica sessions, and maybe film some of that when we get there so that those not attending are also able to benefit. As always, please feel most free to reach out with any questions you may have for your team. And for example, the fact that one of the mentors mentioned the need for support this evening is very helpful, as we also had someone who mentioned that they are a free agent. Maybe we can line them up. And really looking forward to seeing each and every one of you at future events, whether it may be Studica or the CNE or the Stemley Cup or the Windsor Southwest International, or whichever other sessions are before us. So the past training sessions are generally found on our YouTube page. I'll share my screen and see if we can find it here. So if we go to youtube.com and FRC, oh no, First Robotics Canada, sorry. Oh, First Robotics Canada mentor sessions. There we are, First Robotics Canada, and there's a mentor session. There are several of them. The summer mentor training is a playlist from last summer. And then you can see several other ones there from the last 1 or 2 years. So that's a good place to start when looking for the links to past mentor sessions. So once again, hope everyone has a great evening, and looking forward to hearing from you. And yeah, can't wait to see each of your team's robots in just a few more moments in our competition season.
Thank you so much.